Welcome back. Now let us learn the ANOVA. The full form of ANOVA is analysis of variance. Let me explain in a very simple way that how to define ANOVA. You have seen various experiments or the survey done on the various groups, and once this is done, you would like to know that whether the impact is same or different across the group. For example, if you are doing as a medical treatment and to the say two gender, male and female, you have a group of the male patients, you have a group of female patients. Whether the same treatment having a similar effect or the different effect. This is the trying to find it out. It may happen that now if you go ahead and do the further division of the group, say male below 40 years and above 40 years. Similarly, female below 40 years and above 40 years. Is there any impact of the treatment different or depends on the age? That is there any change for the below 40 years and above 40 years? So this is the way when you try to have this kind of things. That is where ANOVA helps you. So one way ANOVA is you have one independent variable. So I provided the example of say male and female, that is one way. But you go ahead and divide the group further as we did taken the age. It means we have two independent variables. So it is the two-way ANOVA. Okay. So this is the two-way ANOVA. And there are many examples for this one. I have put few over here. And so suppose you have that if you are trying to trying to measure the anxiety level at the job interview. Does it really depends upon the income and gender of the interviewee? Does it depends? So here we are having two variables, income and gender. That is it is two-way ANOVA. So these are the few of the examples I have put it over here. And if you see this one, a manufacturer has two different processes to make the light bulbs. And they wanted to know if one process is better than the other. So here we have the only one group, one way, one variable, that is the two different groups. So it is a one-way ANOVA. These are the few of the examples of ANOVA. And this is the hypothesis for one-way ANOVA. This is the hypothesis. And it is mostly used to compare the two means from two independent groups and using F distribution. So null hypothesis, the existing situation, the two means are equal. And alternate hypothesis, the two means are not equal. This is what we want to test. And in case of two-way ANOVA, the alternate hypothesis of the both levels, these two are here. That say we had done some kind of income level. So all the income groups have the equal mean stress. And all the gender group have the equal mean stress. So suppose here this is we are doing the two-way ANOVA test and the both independent variable is one is income, another is gender. So this is the null hypothesis of this one. It talks about, and in case of null, we talk about the existing situation. It means there is not much change. So these two will be tested for the two-way ANOVA. Okay. So similarly, if there is anything third, then third factor will be included. This is the way to build the hypothesis for ANOVA. So let us do the hands-on on ANOVA. Please open that Excel file which is there and the ANOVA tab. So here what we have done, there are some kind of tests done on three tests are done and there is some result. We wanted to verify whether these three tests is different from each other or okay. So if you see that we have only one variable, that is the only one. So test A, test B, test C. And how can we go ahead and do it? So if you select and let us open the tab. Data analysis and ANOVA single factor. Okay. Input range. So I'm selecting over here. This is input range. And this is the level CST here. New worksheet. And this is the result. So it has done some of the basic things like count, sum, average and variance. So there is some way to calculate the ANOVA. So it has done the calculation over here and it has already given the p-value. So if you want to understand, if you want to do the manual thing, then it is what it is trying, that the sum of a square between groups, it means across the group, this is the unit, within the group, and there is a degree of freedom. Degree of freedom has been that this is for between the groups, total number of group minus 1, and this is the total data minus 1. So let me see how much data we have. So we have 5, so 5 minus 1, that is 4, and 3. 4 into 3, 12. That is what it is, 12. And if you see, this is the MS mean MS, this is the division of SS by DF, that is what we see over here. And 35 by 3 is your there's some more calculation over here. I'm not able to recollect, but this is how it gets calculated. And the AP value is taken from the corresponding F statistics. So this is the critical value of the F score, and the P value has been taken. And if you see the P value, it is the less than 0.05. So what is the meaning of less than 0.05? Less than 0.05, that is that we do not have enough evidence to accept the null hypothesis. So we are going to reject the null hypothesis. So it says that as soon as you reject the null hypothesis, as soon as you reject the null hypothesis, it means this is what we are accepting. It means the means are unequal. So what is the business interpretation of this? Business says that the impact of these three tests is different. See, as of now, it does not say that A is different from B or C different from B. What it is, there is a difference. And if you try to look at the data from here, average, it looks like test C is different from test A and B. Test A and B. So if you want to do it see, it is quite obvious from the data that test C is different from A and B. You may also ask the question, what about A and B? It looks similar, but you can test with only these two and see whether they are same or different from statistically. Okay. Now this is the homework. So you have the one sample test. Again, this is a one-way ANOVA. So please do it on your own. And the answer is also hidden over here between row number 33 to 49. If you are unable to, if you are or if once you have solved, please verify your answer with the answer written over here. Okay. And so this is also one more, please, for your homework. In case of two factor, so let me show you the two factor. These are the two factors, and for the two factor also have done the answer over here, so you can go ahead and do it. This was with two factor without replication, and it is a with replication. So this is the things also have done it, and the answer is also already here. Just try to do it on your own, and if you cannot do it, I will help you. Okay, so that's all for ANOVA, and thanks a lot for watching it. And if you face any issue, do not hesitate to write it to discussion board. Thanks a lot.